So this video is for integrated 3. This is on normal distribution classwork number 4, classwork/homework. And on this at the very top, I had this in notes earlier, but when we first learned this is something called a z-score. Now, a z-score, you're going to take the value, you're going to subtract it from the mean, and that's going to give you how far off you are from the mean. So that's going to be how far off you are from the mean. How far off from mean. Now, when we divide that, how far off we are from the mean, by our standard deviations, that tells us how many standard deviations we are away. And that is our z-score. Okay, that is called our z-score. So they want us on this to round our answers to the nearest hundredth. So on number 1, adult males have heights with a mean of 69 inches and a standard deviation of 2.8. Find the z-scores for the corresponding to the following. So for basketball player Muggsy Bogues, who is 5 feet 3 inches tall, we are going to take, first off, I'm going to change 5 feet 3 inches. So 5 feet times 12 inches is going to give me 60 inches. Okay. And then he was 5'3". So that means when I add the 3 inches, he's going to be a total of 63 inches. Now, I want to find the z-score for this. So the z-score, putting x score, z-score, I'm going to take his height, which is 63 inches. I'm going to subtract the mean, and the mean was 69 inches. And I'm going to divide it by the standard deviation, which was 2.8. So here's the mean, which was 69. Here's the standard deviation, which is 2.8. Sorry, yeah, 2.8 inches. Okay, and I'm going to work that out. And let me just do that on my calculator. So when I have 63 minus 69 divided by 2.8, I get a negative 2.14 for my z-score. Okay. So every standard deviation is 2.8, and he is about -2 of those away from the mean. Okay. Now, Shaquille O'Neal. Okay. So he is 7 feet times 12 inches, which is going to push him to 84 inches. And I'm going to be adding 1 inch onto that. So he's going to be 85 inches. And then I'm going to take his height, which is 85. I am going to subtract it from the mean, which is 69. I'm going to divide it by the standard deviation, which is 2.8. And when I do that, let me just do that math. I end up with hold on, I'm putting the wrong amount on my calculator, sorry. I end up with 5.71 standard deviations. Okay, that's his z-score. So if something's normally distributed, Most of the data is within 3 standard deviations. So he's within that. He's outside of that. Okay. Which makes sense because Shaquille O'Neal's pretty tall. On letter C, the Beanstalk Club is a social organization for tall people. Men are eligible for membership if they are at least 74 inches tall. What percentage of men are eligible for membership in this club? Okay, so what I'm going to do is I'm just going to kind of draw this out. We know that 69 is the standard deviation. I mean, is the mean. They need to be 74. And so we want to figure out what percent would be what percent is this up to? Okay. And then the percent that would be eligible are going to be the ones in this category. So I am going to do normal CDF. And in that, I'm going to put my lower bound, which is going to be negative 10 to the 99. Actually, I'm going to do it this way because I want this. I don't want the ones that aren't going to qualify. I want the ones that qualify. So I'm going to do this. So I basically am going to want 74 for my lower bound. Infinity or 10 to the 99 for my upper bound. And my mean was 69 and my standard deviation was 2.8. Okay. So I'm going to, I can just type in normal CDF. I'm just going to find it here under distributions. You guys, you can use the calculators. I'm just doing this just to show us. So for this, I'm going to put in my mean, which is 69. My standard deviation, which is going to be 2.8. I'm going to hit this so I can kind of see that. And then I'm going to find cumulative, and I want to find from 74 to infinity. Okay, on our calculators, we're going to go 10 to the 99. And if I get rid of this, I can see this is the area that I'm looking for, which is this. Okay, right here, I'm at 74. That's 74 on. So that is going to be, our answer is going to be 0.0371, which would be what percent? 3.71% would be eligible. Okay. On number 2, the amounts of time that high school students spend working at jobs each week has a mean of 10.7. So this is unrelated to the height problem. Okay, so has a mean of 10.7 hours and a standard deviation of 11.2 hours. Okay. We want to find the z-score corresponding to a student who works 8 hours each week. Okay, so if I want the z-score, I am going to take the amount of hours, which is 8 hours. I'm going to subtract it from the mean, which is 10.7. I am going to divide it by the standard deviation, which is 11.2. And let's see what I get. Okay, so I'm going to clear that. So I'm going to put my division here. Okay, 8 minus 10.7 over 11.2 gives me a negative 0.24, okay, for our z-score. And that makes sense because I am 11.2. If I was to take, let me just do it here. If I was to take our z-score so if I was going to take 10.7, which is the mean, and subtract, because 8 is less than 10, and subtract the standard deviation of 11.2, you're going to see that I am going to be at a negative 0.8, negative 0.5. Okay. That would have been one standard deviation. That would have been one standard deviation. That would have been at a negative 0.5. And we're at 8. So we are going to be on the negative side, but we're going to be closer. Let me just draw it in pink here. We're going to be closer to the 10 than to that. So a z-score of a negative 0.24 makes sense because it's definitely not negative 1. It's definitely closer to 0. On number 3, women's heights are normally distributed with a mean of 63.6 and a standard deviation of 2.5. The heights of the Rockette dancers at New York City's Radio Music Hall must be between 65.5 inches. So over the mean. Okay, so 65.5 inches and 68 inches. And so we're kind of looking to see here. This is where they need to be. If a woman is randomly selected, find the probability she meets the height requirements. So for this, we're going to do normal CDF, okay, on our calculators. And we're going to put in our lower bound, which is 65.5, our upper, which is 68, our mean, which is 63.6, and our standard deviation, which is 2.5. Okay, and that's going to give us our answer. Okay, I'm going to do it on Desmos here. So let me get my normal CDF. And my mean is 63.6. And my standard deviation is 2.5. Okay. So there's a picture of it. And I want to find between 63.6 and not 63.6, between 65.5 and 68. Okay, so I can see that picture, and that's going to be 0.159, so 0.16. So about 16% as a percent, but 0.16 is what I would round it up to the nearest hundredth. On number 4, replacement times for iPods are normally distributed with a mean of 7.1 years and a standard deviation of 1.4. Find the probability that a randomly selected iPod will have a replacement time less than 8 years. So less than 8 years. So I'm looking for this. So this is going to be normal CDF. And in the parenthesis, I'm going to put my lower bound, which is going to be negative infinity or negative 10 to the 99. My upper bound is going to be 8. So this should be more than 0.5 because this would be 0.5. Okay, so I'm going to be more than that. 8, and then my mean is 7.1, and my standard deviation is 1.4. And again, I'm going to do that over here on this. So let me adjust this. My mean let me just start fresh. Okay, so my normal distribution. Okay, my mean is going to be 7. 0.1. My standard deviation is 1.4. And let me first just get the picture. There's the picture. Okay, there's the picture. And I want it from negative infinity, so I'm going to keep that. Okay, that's really negative 10 to 99 on our graphing calculators to 8. Okay, so that's that. And we see our answer is going to be 0.74. Okay, so about 74%, but they want it as a probability, so just leave it like that. According to Opinion Research Corporation, men spend on average, okay, so that's our mean, 11.4 minutes in the shower. Assume that times are normally distributed with a standard deviation of 1.8 minutes. If a man is randomly selected from the probability that he spends at most 10, what's the probability that he spends at most 10 minutes? So at most, here's the key word here, at most 10 minutes. So 10, we're not going to go beyond 10. Okay, so we want less than 10. That's what we want. So we're going to have a normal CDF. Our lower bound is going to be negative infinity or negative 10 to the 99. Our upper bound is going to be 10. Our mean is 11.4, and our standard deviation is 1.8. So let me get rid of that. Let me change this to a mean of 11.4 and a standard deviation of 1.8. Okay, so there's our picture. So our mean of 11.4 and a standard deviation of 1.8. Now, I'm going to go from negative infinity, which is negative 10 to the 99, up to 10. So we see that's our picture, and that's going to be 0.22 if I'm rounding. Okay, so about 22%. On 6, IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. If we define a genius to be someone in the top 1%, so top 1%, okay, I want to figure out what score that is to be in the top 1%. So what I'm going to do is this is going to be an inverse norm. And if I want to figure out that value, I basically want to have 99% of the people below them. So I want to find an area that is 0.99. That's what I want. And I want the amount, the value that gives us that. So this is going to be an inverse norm. And for the inverse norm, what we do is we do the area, which is 0.99. Okay. We give the mean, which is 100, and we give the standard deviation, which is 15. Okay, now I'm going to be doing it different here. That's what you would type into the graphing calculators. What I am going to do is I need the normal distribution where our mean is 100 and our standard deviation is 15. Okay, that's what I'm looking at. So let me see that. Okay, that's what I'm dealing with. And then what I'm going to do is I'm going to go dot, and I'm going to come here to get, where is it? Inverse CDF. and I want it to be 0.99. And so the score needs to be 134.895. So that's going to push it up to 90. That is the score. Okay. Now I can kind of double check myself if I, whoops, I want to come back here. If I come to my normal distribution, 100 with 15, and let's say that I wanted to go from, well, if I went from negative infinity up to this answer here, let me see if I can copy this. Copy. See if it'll let me paste it. Okay, I'll just type it in. It's not letting me. So let me put in 134.895 211 and you see I get to that 99 if I put that in. Okay, and so the top 1% would be on the other side. Okay. Weights of discarded households. Weights of paper discarded by households each week are normally distributed with a mean of 9.4 pounds and a standard deviation of 4.2 pounds. Find the weight that separates the bottom 33% from the top 33%. So the bottom 33% to the top 67%. Oh, and I shouldn't really do it like that. Bottom 33% to the top 67, from the top 67%. So I won't need to find the score here. That's going to be the bottom, where the bottom 33% is. And then I'll just call this one Y, where the going from here to here is going to be 67%. So this whole area here being 0.67%, which is going to be on the other side of the mean. So I am going to do inverse norm. And I didn't have to write the word inverse out. Inverse norm. Area 0.33, mean 9.4, standard deviation 4.2, and get that answer. Then I'm going to do inverse norm 0.67, 9.4, and 4.2, and get that value. Okay, so let me just clear this out. That's what you guys are going to type in. I'm doing this on Desmos, so it's a little harder on Desmos. So I'm going to put in the information first for the normal curve. So my mean is 9.4. My standard deviation is 4.2. Let me get that picture going. Okay. And then I am going to put in a point, and then I'm going to come get my inverse. And I am going to put in a I'll do 0.33 first. And that is going to be a 7.55. 7.55 would be that particular weight. And then let me do the same here. I'm going to change this to 6.7. And that is going to be 11.24. 247, so 25. 25. So those are going to be the scores. It's going to be in between 7.55 and 11.25. Okay. Quarters have weights that are normally distributed with a mean of 5.67. So a mean of 5.67 and a standard deviation of 0.07. So let me just kind of sketch this out. I like to see it. Okay, so mean is 5.67. Standard deviation, let me just write that here. Standard deviation is 0.070 grams. Okay. If a vending machine is adjusted to reject quarters weighing less than 5.53 grams, okay, so less than 5.53 grams. Okay, so we want this area here. Or more than 5.81. Okay, so more than 5.81. What is the percentage of legal quarters that are rejected? Okay. So I can find each of these separately and add them together. So I could do this. I could do normal CDF of negative 10 9 to the 99, so negative infinity, to 5.53 with a mean of 5.67 and a standard deviation of 0.07, and add that with the normal CDF of the lower bound 5.81 to 10 to the 99, which is infinity, mean 5.67, standard deviation 0.07, and see what I get. Okay, so let me do that on this. Okay, so I'm going to get my normal distribution. Mean is 5.67. Standard deviation is 0.07. Hit this so I can see it. And I want to find it from negative infinity, which is negative 10 to the 99, up to 5.53. Okay. And let me just get this value here. Sec. Okay. And then I'm going to do the other way. So normal distribution, 5.67. And 0.07. And I'm going to go from 5.81 to infinity. And you see, I ended up with the same thing. Okay, so both times I ended up with 0.02, 0.02. They want percentages, so let's say 2275. And this one was also 0.02275. And so when I basically double that, okay, I'm going to times it by 2. Okay, I'm going to end up with my answer being about a 0.0455. So that's going to be about 4.55%. Another way I could have done that is I could have found this area here, okay, this area here, which is what I didn't want, and take it away from 1. So I could have also done it that way, where I'm basically going to take 1 minus whatever I get from my normal CDF, going from 5.53 to 5.81 with a standard deviation of a mean of 5.67 and a standard deviation of 0.07. So if I did that instead, okay, and I did a normal distribution, again, 5.6707. And for my cumulative, I'm going from 5.53 to 5.67. And then I am going to take this and go 1 minus that. Okay. And 4.477. Did I get slightly different? Make sure I put in the right information. Oh, 07, making sure I just put in the right information. Let me just make sure. 5.53. Oh, this wasn't not to this. This was to, I put the mean in 5.81. Okay. So now when I take this and copy this, okay, and put that here, you see I get the same answer, 4.55. Okay. So this would have been 1 minus 0.9545, which ends up giving me the 0.0455 again. Same way. You can do it either way. Okay. On this next one, sorry, I used a lot of that space. Find the weights of the accepted legal quarters if the machine is readjusted so that the lightest 1.5% are rejected and the heaviest 1.5% are rejected. So we want the weights for those. Okay. So I have the same situation. My mean is 5.67. I want the bottom 1.5%. 1.5% and the top 1.5%. So I'm trying to figure out this value and I'm trying to figure out this value. Okay, so what you would do is you would do inverse norm and you would put in the percent, which is going to be 0.015, and the mean, which is 5.67, and the standard deviation, which is 0.07. And then for the other one, we want all the way up to there. Okay, so we want all the way up to here, which is basically going to be 100% minus 1.5%, which is going to be 98.5%. So we're looking for 0.985. So we want 0.985. 5.67 is the mean, and 0.07 is the standard deviation. Okay. Okay, let me start fresh. So I am going to have my mean, which is 5.67. My standard deviation is 0.07. Okay, that's a picture of it. I want inverse norm, so I'm going to put a dot on Desmos and come here to inverse CDF. Skipped it, sorry. There it is. And I want the area, which is going to be 0.015. And so that score for this one, for my lower one, is going to be a 5.52. And then I'm just going to keep this and change this to a 0.985. And that score is going to be a 5.82. So anything higher than 5.52 would be thrown out, and anything, lower than 5.52 would be thrown out, and anything higher than 5.82. So the accepted ones would be in between that. So the accepted ones would be in between 5.52 and 5.82. Those would be accepted. Okay. The height of boys at a particular school following normal distribution with a standard deviation of 5 centimeters. The probability of being shorter than 153 centimeters is 0.075. Okay, so we need to find the mean. We don't know the mean. Okay. We do know the standard deviation is 5 centimeters. Okay. 5 centimeters. So I know that at 153, that this area is going to be 0.705. And I need to figure out what the mean is, knowing that the standard deviation is 5. So what I'm going to do is I am going to do this using a standard normal curve. Okay. So if I was to draw, if I was to draw a standard normal curve, my mean would be 0. My standard deviation would be 1. I want to figure out for that what value, okay, because that would be the standard deviation in this case. What value would make it be that this is 0.705? What value? So I'm going to get my, so if I was doing this on my graphing calculator, I would do inverse norm. My area is 0.705. Let me do this below. My area is going to be 0.705. My mean would be 0, and my standard deviation was 1. I know that's not what it is. I just want to find out what the z-score basically would be. Okay. So I'm going to go to a normal distribution. I'm going to put in, well, I'm just going to have it be normal. So this is normal. If I don't put anything in, it's normal. Okay. And I want to get the inverse CDF of 0.705. Okay, and I see that that would be 0.5388. Okay, that's how many deviations away I would be. Now, each of my deviations is 5. So what I'm going to do is I'm going to take that 0.5388. I'm going to times it by 5. And I'm going to add that. I'm actually going to take that off of. Let me move this. I'm going to subtract it from my 153 because if I was 1 deviation off, that would have been 5 off. Okay, but I'm not a full deviation. I'm 0.5388 deviations away. And each of those deviations is 5 centimeters. So I'm going to take 153 minus 0.5388 times 5. And I'm going to get 150 point, let's say 31. And I'm going to see what I would get if I just did this to the nearest hundredth. Okay, so 150.3. Let's round it to about that, 150.3. Okay. That is my mean, 150.3. Now that we got that, and again, I figured out using a standard normal curve, okay, how many deviations away I would be at 70.5%, okay? And then I times my deviation, which is 5 centimeters, times how many deviations away I was, which I wasn't even a whole deviation away. And that's how I got that answer. Now, the next one, I'm going to find the probability of a boy being taller than 156. So if my mean is 150.3, and I want to see what's the probability of them being above 156 more than. So I'm over here. What I'm going to do in this case is I'm going to do normal CDF. Okay, let me get rid of that. Normal CDF. Lower bound 156, upper bound 10 to the 99. Mean 150.3, standard deviation 5. Put that into my calculator. Okay, so I'm doing it on Desmos. Okay, so my mean is, I have to put my mean in first on mine. So it's going to be 150.3. My standard deviation is 5. Okay, that's a picture of that. I want cumulative, and I'm going to go from 156 to infinity, or 10 to 99 for you guys. And I get a 0.127, so a 0.13 as my answer. And that's the end of this video.